All right, we're back, and it's COMP123 week 4, lesson 4, part 6. 6 parts to this one. And we're doing a little poll now for those people who are physically in the class. And I will, here's the poll. If a base class, the first one, if a base class and a derived class have methods with the same names, but different parameter lists, the derived class method overrides the base class method. A, true, B, false. So if a base class, I'll read it again, if a base class method, the superclass, and a subclass have methods with the same names but different parameter lists, the derived class method overrides the base class method. What's the answer? A or B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I had 25 people today, so I need at least 25 answers. Or in that range. Please answer your questions. You can do it through the web response, pollev.com/learn, as well as you can text it if you want to through your phone, whatever's easier for you, if you don't have access to the web for some reason. I've got 18, 19, 20. You're looking at this question, and some of you are like, but I don't understand it. What do they mean by this? Right? And there's some tricks when it comes to these multiple choice questions. I'll give you another minute or so to respond. Some tricks here. Right? There's 21. A few more people haven't responded yet. If you haven't responded, please respond now. I'm going to shut it down in a second. It's good. Look, it's a good chance for you to practice in a safe environment. There's no one that's going to know who responded, right? No one knows if you made a mistake. Make it now. It's better now than later, right? All right, that's good enough. 23. So there's a couple people that didn't respond. So sad. Let's think about this. A base class or a superclass and a derived class or subclass have methods with the same names but different parameter lists. When you see that, right, those methods are different. Because if I talk different parameter lists, right there, we're talking about different method signatures. Different method signatures are overloaded methods. And I can overload a method that exists even in my own class, never mind the superclass, right? So if I overload a method, I don't override my base class method, right? Because my signature is different. I can only truly overload or rewrite a method from my base class, right, if the signature is the same. So in this case, it's false, the answer. Tricky question, all right, but makes sense. Okay, let's go to the next one. The keyword blank always refers to the superclass of the class in which you use it. A, super, B, parent, C, upper, D, base. We're talking C#. I'll wait for a couple more responses. That's good. All right. Even though I sometimes refer to the base class, which is what it is, the base is the right answer, as parent or super, right? I might refer to it to talk about when I talk inheritance, right, or object-oriented programming. In the language itself, the keyword is this key part of the question here. The keyword base is the one you can use. I might describe a parent class or a superclass, but I can't use super or parent in this context in C#. It's only base that I can use when it comes to a keyword, right? I can describe object-oriented programming concepts by using super and parent, but I can't use super or parent in C#. Super is something we use in other languages. We can use it in with JavaScript, especially the new version that's coming out, ECMAScript 6. We can use it in Java itself and other languages, but not in C#. Okay, a superclass contains all the fields and methods of its subclasses, as well as its own more specific fields and methods. Read this carefully. A superclass contains all the fields and methods of its subclasses, as well as its own more specific fields and methods. We got a few responses left. I'll give you a couple more minutes to answer this one. I know for some of you, you've answered. You want to know the answer, right? You can honestly see that there's more people going on the false side than the true side, right? And this is a good indicator of where people are thinking. And I think that's why I like these polls. It's like, hey, this is where my thinking is at, right? Have I taught you properly? It looks like you're on the right track because I'm just going to stop it now. The answer is false. And let me tell you why, all right? A superclass contains all the fields and methods of its subclasses? Not necessarily. If I make a subclass, if I'm subclassing, it's because I want to add additional methods. If I was going to talk which one is bigger, 90% of the time, the subclass is greater than the total of methods and properties of the superclass. The superclass is small. It gives you a base of stuff that you can use, and our subclasses add to the superclass. So therefore, there's going to be stuff in the base class that the superclass does not include, right? So in this case, it's easily false, right? Now it also says, as well as its own more specific fields and methods. Well, specificity, when we speak specificity, we're talking about our base class, our subclass, not our superclass. So if you think about it, the base class, superclass, parent class, from an object-oriented programming perspective, is where we have a very general amount of properties and methods. We become more specialized as we create our subclasses, or another word for them is derived classes, child classes. The more we derive, the more we go down the hierarchy, the more specialized we get. So when I talk specialization, you know I'm talking about a subclass, not a superclass. Superclass has as little specialization as possible because you want more other classes to pull from it or inherit from it. I'm not sure if I have any more. I do. A blank is a synonym for a derived class. Now we're talking synonyms, not keywords. These are easy questions, but again, some of them it's part of the way you read the question sometimes. Remember, multiple choice questions are trying to trick you, right? There's a piece of it that's trying to say which one is, what is this thing? Now in this particular case, there's no trick. It's very simple. Some of them are very easy. I find that true and false questions are harder than multiple choice because you have a 50% chance to be wrong, right? Whereas this one here, you could be 75% of the time wrong, right? But 50%, I mean, you could obviously see there's one that doesn't make any sense. If I was going to do multiple choice, I would say, okay, a subclass would probably be the answer, right? Because you know what? Blank is a synonym for a derived class. Derived can't be the parent class, can't be the superclass, can't be the base class. must be the subclass. This would have been a better, harder question if I said a blank is a synonym for a derived class where you had a couple of other choices that were similar to subclass, but not subclass. Like if I called it sub, right? And you'd be like, sub, is that it? Right? Because that's kind of a trick, right? I didn't use the whole word. I used part of the word, sub, instead of subclass, right? Anyway, that's it for the poll today. So again, it's just trying to get you to understand the terminology. When I do multiple choice on an exam or a test, I'm testing for knowledge. I'm saying, can I get you to give me the knowledge I'm looking for, right? And that's why it's okay if it's open book, because I'll tell you right now, if you only have an hour and it's open book, and if you don't know the answers, it's not going to help you, right? Open book to me, the reason why I say open book is some of you might search Google, right? Because it's going to be open internet too, right? You're going to go, oh God, I got to get this done. But there are going to be some tests that I ask you to do that no matter what you do on Google, it won't give you the answer. It's got to be up here to understand how to program. So one piece of it's going to be practical, and one piece of it's going to be knowledge-based. Sure, you can spoof the knowledge, right? I don't recommend it though, right? I think you should try and figure out, study a little bit and understand stuff, right? And use these things. And when we talk, these things I'm talking about, I will only test you on the things that we use most often. I'm not going to test you on things like the new keyword when it comes to information hiding, right? I'm not going to do that because I'm telling you, I wouldn't use it. So if I'm not going to use it in general, why would I test you on it? To mess you up? No, that's not what we're here for. We're here to learn. We're not here for me to mess you up so you don't get high marks. It's not about that for me at all. It never will be, right? Okay, so let's go and talk about this super object that belongs to C#. So there is something called the object class, capital O, right? Which is part of the system namespace, and it is where all classes derive from. Remember we had these other little keys, like these other little properties that existed within our own classes, our custom classes we created. Like for example, if I go back to my program here, right, and I start typing my villain like this, you don't have to do this, you just watch. And if I go dot with the dot accessor, I get does bad things, which is part of the villain class, right? But I also get equals, get hash code, get type, and toString. Well, equals, get hash code, get type, and toString belong to the object super class that all custom classes and other classes derive from, right? So I always have access to those four methods, always. They may not mean anything for me. It may be meaningless to me, right? But remember that all custom classes are also part of the object class, right? So if I was to test to see if my villain was an object, part of an object class, if it was part of the same class, it's true. The answer would be true. It is part of the same object class. It's just a very specialized version of the object class. So let's talk about hierarchy for a second before we go on. And you know what, for this, it's like me drawing on the board. So I'm going to pull up my little tablet, right? Because I think we need to have this hierarchy discussion here before we get into further discussions about what I'm talking about. Okay. So let's suppose, see if I can turn this thing on. Oh, there it is. Oh no, it's gone. Oh, there it is again. I'm going to go into Sketchbook Pro for a second, and let's do a little drawing. Okay, so just imagine that this is my little, my little board. So again, I'm going up to draw my superclass. So imagine my superclass. That's not what I wanted to do. La, la, la. Imagine my superclass, right, as the top of the hierarchy chain. Actually, I use little bubbles instead of squares because I like bubbles better. Okay, not that one. I meant this one, I said. So here's a bubble. This is my superclass, okay? And then what I want to do, right, is I want to draw a line to my two subclasses, right? So here's my line. This is the same thing I would do on the board, guys. So people at home can see what I'm doing. Now, this is going to be weird, right? But anyways, I've got these like my hero class, and it's going to be kind of weird here, but the great thing is it doesn't matter. You get the picture if I drew it this way. Here's my superclass, right? So I'm just going to kind of put this in here and type super, right? And my super, let's move this over here on the top of my thing. So here's my superclass. And I have my subclasses, this one and this one, right? So in my subclasses that I have in this hierarchy, right? My superclass is at the top. But above my superclass right now, and again, if I was to kind of let me just turn on touch for a second, and just yes, there we go. Over on top of my superclass itself is another class, right? Of course, I'm getting a different pattern. It's okay because I don't want this. I drew it, but you know how it is when you're using a new tool. I wanted to do this, for God's sake. And of course, it's going to draw off screen because I'm not doing it properly. So here it is. This is my object class. My object class in the hierarchy chain, right, is above my superclass, right? So if I had my superclass, and here's one of my base classes down here, here's my object class. I'm just going to label that as an example for you. The object class is above all other classes. Now remember, when we say is a, we have a relationship, and in the book it always tells you things like that, right? It says we have a relationship that's is a. Is my superclass an object? What do you think? The answer is yeah. It's part of the object superclass, right? And here, in my subclass, is my subclass this superclass here? And the answer is yeah. It is. It is the superclass plus. As I go down, if you notice, and see how this widens out, and if I can continue to draw this, very simply here. But if I draw a couple more legs here, so I make a couple of more classes that are derived from my subclass, you get what I'm talking about here, even if I'm drawing it incorrectly. The idea here is that in the hierarchy chain, this one down here in the hierarchy, is it a superclass? This thing, the super? It is. It doesn't matter what I call it. This is my superclass that I derive the other classes from. But in the hierarchy chain, this is also a part of the object class. So is this one. And even if I go further down, as I go down, you're going to see that every one of them derives still from the object superclass. Right? That's the thing to understand. The object superclass, this object superclass, all the other classes that I'm drawing here, and I'm just going to draw these little bubbles so you understand what I'm talking about, right? They derive, as we go forward, right, from this class here. Everything comes from the object class. That means all of these other classes, these other nodes in our hierarchy, right, contain elements of the object class. And because every other node in our hierarchy so far is a derivative of our superclass, in this particular case that I've named super, right, they also have the same properties as a superclass, right? And if I was to number these things, so if I say, I'm just going to go back to this for a second now. So I'm just going to undo this. And if I was to draw, I'm going to actually just unclick that. So I'll physically try and draw the artist that I'm not, right? So here's number one, here's number two. And by the way, I'm looking at the screen, which is always more difficult than actually looking at a Cintiq. This is the third layer. Here's the third layer, and this is the second layer. This is like the second level of hierarchy. And down here is the fourth level of hierarchy, right? Now, this fourth level of hierarchy, here's the first level of hierarchy. At the second level of hierarchy, both of these subclasses have the same, pretty much, they're the closest to the superclass. And they're probably the least specialized at the second level compared to the third level and the fourth level. So if you think about it, this fourth level down here, right, or this one, is bigger and would be bigger, chances are, than this one. But you can't tell. It's not 100%. This could be a very big class, right? They could include different elements that make it quite big, right? But the specialization is all these classes here that are in the hierarchy chain have the same or similar methods and properties as we go down, right? But for this one, as an example, this little orphan over here in the corner, right? This may be very different when we come down here at the third level, because it might have similarities to its sibling over here, but lots of different things can happen here. So when we look at the hierarchy of the class hierarchy, remember that the object class is always at the top of the food chain. Everything inherits from it. So every other object is going to have those 4 methods: toString, right? The hash that we saw, and so on. But and if I'm derived for every other method here in this particular choice, in this particular diagram, right? If everything is inheriting from this custom superclass that I'm creating, right? Everything is, then every one of these subclasses have similarities to the superclass, because they're going to have at least the properties and methods of this superclass, whatever it is. But it doesn't mean that this one is similar to this one, other than what we have from its superclass. Because in this level, in this particular area right here, if I circle this one, this is the superclass for these classes. But this is not the superclass for this one. This is a sibling of this one and has the same methods and properties that it derived from our superclass. It's very simple. I'm just saying the same things over and over again. But I want you to see it from a diagrammatic perspective. So when you see it, you look at it and you're going, okay, all right, so I'm deriving stuff from one class to the other. That's all I'm doing. A very simple diagram. And I apologize for my lack of artistry. I'm not an artist. I'm a developer, right? Let us wipe this out, because we may need to draw on it again. And I'll move on. The idea is very simple. It's the implementation that often becomes hard, right? When we think about it from a business rules perspective, and we think about the object as the top level class, we think about that our object gives us the ability to do different things. For example, I can test. If I say I'm creating in my program, here's my program main, as an example, I'm passing in an object, the whole object itself. So I'm not passing in, as an example, a property anymore. I'm passing in the object. I can do that, right? Because I can listen for a type of object that's inside my method. So the method can also, as a parameter, take an object, right? And I can specify it for whatever the object is. I can be specific and say, the method is listening for, if I'm going to make a method that's listening for the hero or a villain, I can say, I'm passing in a hero object or a villain object. When I create a custom class, right, I'm creating a custom data type as well, if you think about it, right? So it has a value, right? The value is in the constructor. The constructor is what returns into my object. So when I have that assignment statement, when I do this, employee clerk is equal to new employee, I'm actually using an assignment statement here, right? This equal sign is saying, take my employee constructor, the value that I'm getting from my employee constructor, whatever it is, and assign it to this clerk variable, right? And of course, the clerk variable, I'm going to shape it and make it the same shape as an employee. That's what I'm doing here when I say this. Different ways of thinking, right? So therefore, if I pass in an object, clerk, into this display object message, into this method, right? Then it would go in, because, as an example, even though clerk is of type employee, it's also of type object, right? Because every custom object we create is of type object. Remember, just like the hierarchy says, right? Even though it's also, the specialization makes it we call it an employee. That is our new custom class, right? But employee is a subclass, and it always will be by default of the object superclass. So therefore, if we pass it in here, it wouldn't give you an error, because clerk is an object of the object superclass. A little bit difficult to understand sometimes, and I apologize, but these are the ways that as we go forward, you need to look at these things. Equals, get hash code, get type, and toString are all the different ones that come from our object superclass. Equals, again, determines whether the two objects instances are equal. So if I say this instance is equal to this one. That's what I'm actually doing. Are they the same? I could ask that question. Not always has not all of these have a use. Get hash code is a unique code for each object. When you get a code, when I store an object in memory, I get an actual hash code, so I can differentiate between object 1 and object 2 from the same superclass, the same class. So I might have my hero 1 and my hero 2. They're different objects with unique properties, right? Property values, sorry, that are instantiated from the hero class, right? And each of them has a unique hash code to differentiate them. So I can listen for that hash code, and it's different. Get type, where it actually returns the class, the type or the class of the object. Because remember, all types are actually objects in C#, right? So if I was going to use the get type method, it'll return what type it is. So if I made a custom class called hero and I use the get type on it, it would say hero, right? So you can always check to see if a type is hero. And this is good because if I want to test, if I only want to do an operation on a hero, but not the villain, and I'm passing an object, generic object into a method, I can test whether it's a hero or what am I getting here, a hero or a villain that I'm doing the test on. And toString, I return a string. It converts the object into a string that I can output into the console, right? So here's my object, and this string represents the object. It gives me the object with to understand if I want to use this to test with, as an example. Again, these are neat little utility methods, not always usable. So here's an example of how it's used in the console.writeLine for the getType method. Same thing for toString. If you want to get the type as an example and you want to convert it to string, as an example, you can override it. By the way, you can override methods that are built into the object superclass, superclass. So if you wanted to override the toString and make it do something else, you can do it. It's not a big problem, right? And this is a good example of how we use polymorphism, right? Many shapes, polymorphism, to reshape the built-in method that comes with our object superclass, toString, right? Because we're using the override keyword to override the built-in method. Okay, that's what we're doing here. Same thing with equals. I'm not going to go over these because some of these we're not going to use. But the idea is we override methods that are built into our superclass. Okay. I'm not going to go over the hash code a little bit. And we talked about base class constructors in the first part of this class. So I'm going to kind of go through here. And I'll quickly talk about abstract classes before we depart, because this is all I need you to know about abstract classes. So again, there's two types of classes. One that is concrete, creates concrete objects, and one that creates abstract objects, right? Or objects that are not concrete. Concrete objects are made from classes that are instantiated, right? If I make an abstract class, I never can create a concrete object from it because it's abstract. It's almost like a design pattern that I'm going to use to create other classes, but never ever instantiate. Just like my character. I would never instantiate my character class. So therefore, it's best to think about it as a superclass that's abstract. All right? So again, an abstract method, right, has no method statements. It's just almost like a design pattern. So I say, here's the method. I talk about the signature of the method, but it doesn't have a body at all, right? And a derived class, if I call an abstract method, the derived class or subclass must override an abstract method. An abstract class, right, when I use the abstract keyword, I can contain abstract methods, but some methods are not, I don't have to put methods in there at all, and I don't have to, I can include or not include a method body. Because some methods will be abstract in my abstract class, and some methods won't. Remember, and think about it as a design pattern, right? And when I include my abstract class, I force you to override the methods that I tag as abstract, right? Maybe I make these abstract methods empty, right? And I force you to write them because I want you to adhere to the shape of your subclass, and that's why I make them. And this is where, again, it becomes very, very challenging. Will I test you? Will I test you on abstract classes? No. That's crazy, man. I'm not going to test you on it because to me, abstract classes and even polymorphism in some ways is almost like an advanced next level thinking for young programmers like yourselves, right? You need to know it. I might ask you questions about on the exam, but I'm not going to ask you to write an abstract class or use an abstract method. I'm going to show it to you. I'm also going to show you interfaces, but I'm not going to ask you to implement them right now, even with an assignment, because it doesn't make any sense, right? I don't want to burden you too much with some of this stuff because it becomes hard to absorb it all. But let's look at this. So here's an abstract class animal, character, right? Animal really isn't a good context, right? It's not something that we would ever want to instantiate. If I look at an animal in real life, I don't say, that's an animal. I say, that's a cat. That's a dog. That's a tiger. That's a lion. I don't say, that's an animal. Unless I say, if I refer to the set of all animals, right? A dog and a cat are both animals. I might talk about them like that. And I could say that the cat is an animal because it's true. It is an animal, right? But it doesn't mean that I would refer to it as an animal. I would say, that's a cat, right? In the same way, we can create an animal abstract class, right? But I would never instantiate an animal. I would instantiate a cat or a dog, right? Because there is no like animal. I can't look at an animal object. There's no like generic animal in real life, right? So there, we would never instantiate an object of an animal, if it makes sense. It's like saying, I want to make a generic person. What does a generic person look like? It would be androgynous, right? There wouldn't be any gender, because if I was to create this thing that I'm talking about here, right? And I don't know what his or her coloration would be, what kind of hair they would have, eyes, nose, shape. There'd be no shape because we're all different people. We all look different, right? And we're all different. And we have to celebrate our differences, by the way, as an aside, right? We have different preferences and all that kind of stuff. I can never create an abstract person. I can't just say, hey, here's an androgynous person that has no preferences. It doesn't exist. You'll never see that, right? Well, at least not in my lifetime, right? So, you know, at the same time, we can't abstract and create an animal, a rough animal, right? And again, it has an abstract, if you notice, it has an abstract method here that is called speak, right? But there's no method body. Here we've designed, and it returns a string, right? A string is the return type. So it's going to return some kind of string. That's the required signature for the abstract method speak. But I don't have a method body in here. I need to make the method body in my derived class or subclass. So here is this method speak, and it has to have the same access modifier and return value. But I need to use the override keyword and then return something. In this particular case, when a dog speaks, it says woof. And when a cat speaks, it says meow, right? So I must override all abstract methods. I must override. I think I'm going to leave it there for you guys. So again, when we talk about the test for next week, what am I testing you on? I'm not going to test you on abstract methods. I'm not going to test you on abstract classes or those kind of things. Your test for next week is going to be based on simple inheritance, okay, with a little bit of polymorphism, okay, little bit. I'm talking about like minor changes. If you're gonna override something, you're going to use the virtual keyword, right? Virtual keyword with an override keyword on the receiving method to change it, right? To morph it. But that's as far as I'm going to go, right? I'm not going to ask you to take an abstract class and form a base class from it. We'll talk about it again. Well, I'll do a little bit of a lecture more on polymorphism on next week, our first part. But I won't test you on it the next day. It doesn't make any sense. Okay? So until next week, good luck with your hero classes. I know if I didn't have a chance to come around and talk to you guys. If you want to talk to me after class for 5 minutes before I go to the next class, I can do that.